It's brilliant, the King of glory, the King above all kings. This is amazing grace. This is unfailing love.
This session explores some questions concerning numbers which are commonly asked in today's competitive examinations.
That you would bear my cross.
Let's get to questions. Find the greatest 3-digit number which is exactly divisible by 17. Let's see how we can find the answer. Let's consider the largest 3-digit number, which is 999. Divide the number by the given divisor 17 and take its remainder. Here we get remainder 13. Subtract remainder 13 from the largest 3-digit number 999. Then we get 986. When we divide 986 by 17, we get remainder 0. That is, 986 is exactly divisible by 17. Thus, 986 is the greatest 3-digit number which is exactly divisible by 17. Let's find the answer. Divide 999 by 17. 20 is the nearest digit to 17. And we know that 20 into 5 equal to 100. So let's assume that 99 includes 17 5 times. 7 5 35, write 5, 3 remainder, 1 5 5 plus 3 8. 99 minus 85 is 14 and drop down 9. And we know that 20 into 8 is 160 and 20 into 7 equal to 140. 149 is greater than 140, so let us assume that 149 includes 17 8 times. 8 7 56, write 6 and remainder 5. 1 into 8 is 8, 8 plus 5 is 13. 149 minus 136 leaves remainder 13. Subtract 13 from 999, we get 986. 986 is a multiple of 17 and which is exactly divisible by 17 without leaving any remainder. Answer 986. Next question. What's the least number which should be subtracted from 7315 to get the greatest number less than 7315 and which is exactly divisible by 15? Let's see how we can find the answer. Divide the given number 7315 by the given divisor 15. Then we get remainder 10. On subtracting the remainder 10 from 7315, we get 7305. 7305 is a multiple of 15 and which is exactly divisible by 15. Let's find the answer. Let's divide 7315 by 15. We know that 5 times 15 is 75. As 73 is less than 75, let's assume that 73 includes 15 4 times. 4 into 15 is 60, remainder 13, drop down 1. Let's find 8 times 15. 8 into 10, 80, 5 into 8, 40. That is 120. 131 includes 15 8 times. 131 minus 120 equal to 11. Drop down 5. So 115 includes 15 7 times. 15 into 7 is 105, remainder 10. Answer 10. Next question. Find the number which must be added to 6482 to get the least number greater than 6482 and is exactly divisible by 19. Let's see how we can solve this problem. When we divide the given number 6482 by the given divisor 19, we get remainder 3. We require a number which is greater than 6482. So we shall subtract the remainder 3 from the given divisor 19. Then we get the number 16. On adding 16 to the given number 6482, we get the number 6498. When we divide 6498 by 19, we get remainder 0. Thus it is clear that to get the least multiple of 19 greater than 6482, we must add 16 to 6482. Let's find the answer. Let's divide 6482 by 19. We know that 20 into 3 equal to 60. So let's assume that 64 includes 19 3 times. 3, 9, 27, write 7 and remainder 2. 1, 3, 3 plus 2, 5. 64 minus 57 is 7 and drop down 8. We know that 20 into 4 equal to 80. So let's assume that 78 includes 4 times 19. 4, 9, 36. Write 6 and 3 remainder. 1, 4, 4 plus 3, 7. 78 minus 76 is 2 and drop down 2. 22 includes 19 one time. 22 minus 19 is 3. 19 minus 3 is 16, which is a number which must be added to 6482 to get a multiple of 19 greater than 6482. Answer 16. Next question. Find the least number which is greater than 1200 and is exactly divisible by 17. Let's see how we can solve this problem. On dividing 1200 by 17, it leaves remainder 10. On subtracting the remainder from the divisor, we get 7. On adding 7 to 1200, we get 1207, which is the least number greater than 1200 and which is exactly divisible by 17. Let's find the answer. Divide 1200 by 17. 7, 7, 49, write 9 and remainder 4. 1 into 7, 7, 7 plus 4, 11. 120 minus 119 gives 1. Drop down 0. As 10 is less than the divisor, put a 0 at the quotient. Then we get remainder 10. Subtract 10 from the divisor 17, we get 7. Add 7 to 1200, we get 1207, which is the least number greater than 1200 and is exactly divisible by 17. Answer 1207. Next question. Which is the greatest 3-digit number less than 999, exactly divisible by 13? Let's see how to find the answer. Divide 999 by 13. On dividing 999 by 13, we get remainder 11. On subtracting the remainder 11 from the given number 999 gives 998. 988 is the number which is exactly divisible by 13 and is less than 999. Let's find the answer. Divide 999 by 13. Seven, 3, 21, write 1, remainder 2. 177 plus 2, 9. 99 minus 91 is 8. Drop down 9. 6 into 3, 18. Write 8 and remainder 1. 166 plus 1, 7. 89 minus 78 equal to 11. That is remainder 11. Subtract 11 from 999. Then we get the number 988. Answer 988. Next question. Which is the greatest number less than 1493 exactly divisible by 7? Let's see how can we solve this problem. Divide the given number 1439 by 7 and take its remainder. When we subtract the remainder from the given number 1439, we will get a number which is exactly divisible by 7 and is less than 1439. Let's solve the problem. Divide 1439 by 7. 2 times 7 is 14, remainder 0. Drop down 3. 3 is less than 7, so put a 0 at the quotient and drop down 9. 5 times 7 is 35. 39 minus 35 equal to 4. The remainder we get is 4. Subtract the remainder 4 from 1439, we get 1435. 1435 is the number which is exactly divisible by 7 and is less than 1439. Answer 1435. Next question. Which is the least 3-digit number less than 412 exactly divisible by 3? Let's see how can find the answer. The required number is the least 3-digit number. The least 3-digit number is 100. So let's begin from 100. 100 is not a multiple of 3. When we divide 100 by 3, we get remainder 1. Subtract the remainder from the divisor, that is 3 minus 1 equal to 2. On adding the 2 to the least 3-digit number 100, we get 102. 102 is the least 3-digit number which is exactly divisible by 3. Let's solve the problem. Divide the least 3-digit number 100 by the given divisor 3. 3 times 3 is 9, remainder 1, drop down 0. 3 times 3 is 9, remainder 1. That's on dividing the least 3-digit number 100 by the given divisor 3, we get remainder 1. On subtracting the remainder from the divisor, 3 minus 1 equal to 2. Add the 2 to the least 3-digit number 100, we get 102, which is the least 3-digit number which is exactly divisible by 3. Answer 102. Next question. If sum of two numbers is 1387 and their difference is 763, find the greatest number. Let's see how we can find the answer. When sum and difference of two numbers is given, and as for the greatest number among them, add the given sum and difference and take half of it. That must be the greatest number among them. We can use a formula to find the greatest number from the sum and difference of two numbers. That is NL equal to S plus D by 2, where NL is the largest number, S is the sum of two numbers, and D is the difference of two numbers. Let's solve the problem. We know that NL equal to S plus D by 2. And given that sum is 1387, difference is 763. Keep this data in your mind or mark in your question paper and follow the next step. Add the given sum and difference together. 7 plus 3 is 10, write 0 and leave remainder 1. 8 plus 6 is 14, 14 plus remainder 1, 15, write 5 and leave remainder 1. 3 plus 7, 10, 10 plus remainder 1, 11, write 1 and leave remainder 1. 1 plus 1 is 2. Divide 2150 by 2. 2 by 2 is 1. Write 1 at the quotient. 1 is less than 2, so put a 0 at the quotient. 15 by 2 is 7 and remainder 1. 10 by 2 is 5. Answer 1075. Next question. If sum of two numbers is 1426 and their difference is 1368, find the least number. Let's see how we can solve the problem. To find the least number from any two numbers from their sum and difference, subtract the difference of the numbers from the sum of the numbers and divide the result we get by 2. The number we get must be the least among the two numbers. We can use a formula to remember the steps. NS equal to S minus D by 2. Where NS is the smallest number, S is the sum of two numbers, and D is the difference of the numbers. Let's solve the problem. We know that NS equal to S minus D by 2. And given that the sum of two numbers is 1426 and their difference is 1368. Subtract the difference from the sum. The unit digit 6 is less than 8, so take 16. 16 minus 8 is 8 and 11 minus 6 is 5. 3 minus 3 is 0, 1 minus 1 is 0. NS equal to 58 by 2. That is 29. Answer 29. Next question. If sum of two numbers is 46 and their difference is 12, find product of the numbers. Let's see how we can solve this problem. To find product of two numbers from their sum and from their difference, add the sum and difference together and multiply it by the difference of the numbers from the sum of the numbers and divide the resultant number by 4. Then we will get a number which must be the product of the two numbers. That is 46 plus 12 into 46 minus 12 by 4. We can use a formula to remember these steps. That is P equal to S plus D into S minus D by 4, where P is the product of two numbers, S is the sum of the numbers, and D is the difference of the numbers. Let's solve the problem. We know that product of the two numbers P equal to sum plus difference into sum minus difference, the whole divided by 4. And given that sum is 46 and difference is 12. That is, sum plus difference is 46 plus 12 is 58, and sum minus difference is 46 minus 12 is 34. That is 58 into 34 by 4. On dividing numerator and denominator, 4 by 2 is 2 and 34 by 2 is 17. Again 2 by 2 is 1 and 58 by 2 is 29. That is 29 into 17. For easy calculation, split 17 by 10 plus 7. 29 into 10 is 290. 29 into 7 is 9, 7, 63. Write 3 and remainder 6. 2 into 7, 14. And 14 plus 6, 20. On adding 203 to 290, we get 493. Answer 493. Next question. If sum of two numbers is 37, their difference is 13 and their product is 300, find the least number. Let's see how we can solve this problem. When sum of two numbers, their difference and their product are given and ask for the least number, divide double of the product by the sum of the numbers and their difference. We shall use a formula to remember these steps. That is Ns equal to 2p by s plus d, where Ns is the smallest of the two numbers, p is the product of the numbers, s is the sum of the numbers, and d is the difference of the numbers. Let's solve the problem. We know that Ns equal to 2p by s plus d. And given that sum of the numbers is 37, difference of the numbers is 13, and product of the numbers is 300. Ns equal to 2 into 300 by 37 plus 13. 37 plus 13 is 50. Cancel zeros in numerator and denominator. Divide numerator and denominator by 5. Then we get 6 by 1. 2 into 6 equal to 12. That is, the smallest of the two numbers is 12. Answer 12. Next question. If sum of two numbers is 30, their difference is 4 and their product is 221, find the greatest number. Let's see how we can find the answer. If sum of two numbers, difference of the numbers, and product of the numbers are given and ask for the greatest number, divide double of the product by the difference of the numbers from the sum of the numbers. The number we get must be the greatest of the two numbers. We can use a formula to remember these steps. That is NL equal to 2p by s minus d, where NL is the largest of the two numbers, p P is the product of the numbers, S is the sum of the numbers, and D is the difference of the numbers. Let's solve the problem. We know that NL equal to 2P by S minus D. And given that sum of the numbers is 30, difference of the numbers is 4, and product of the numbers is 221. That is NL equal to 2 into 221 divided by 30 minus 4, where 30 minus 4 equal to 26. On dividing numerator and denominator by 2, we get 1 by 13. Again, on dividing numerator and denominator by 13, we get 17 by 1. That is 22 includes 13 one time, remainder 9, and 91 includes 13 7 times. Thus we get 17 by 1. Answer 17. Next question. A number when divided by 11 leaves the remainder 8. Its quotient is divided by 14, leaves the remainder 11. What will be the remainder when the number is divided by 154? Let's see how we can find the answer. As the third divisor is the product of first and second divisors, and to find the third remainder, we must add first remainder to the product of first divisor by the second remainder. Let's solve the problem. To find the third remainder, we can use the formula R3 equal to D1 into R2 plus R1. That is 11 into 11 plus 8. That is 121 plus 8. That's equal to 129. Answer 129. Next question. A certain number when successively divided by 7 and 9 leaves the remainders 6 and 8 respectively. What's the remainder if the same number is divided by 63? Let's see how we can find the answer. Here we can see that the third divisor is the product of first and second divisors. So I have to find the third remainder, add first remainder and the product of first divisor by the second remainder. Let's solve the problem. We know that the third remainder equal to first divisor into second remainder plus first remainder. That is 7 into 8 plus 6. That equals 56 plus 6. That equals 62. Answer 62. Next question. How many multiples of 7 are there below 289? Let's see how we can find the answer. To solve this problem, we must choose the upper limit first. The numbers asked for is below 289. So we shall fix the upper limit. 289 minus 1 equal to 288. On dividing 288 by 7, we get quotient 41. That is, there are 41 numbers which are exactly divisible by 7 below 289. Let's solve the problem. The number asked for is below 289. So we shall subtract 1 from 289. Then we get 288. Thus we shall fix the upper limit 288. Divide 288 by 7. 4 into 7, 28. Remainder 0, drop down 8. 177, remainder 1. We get quotient 41. That is, there are 41 numbers which are exactly divisible by 7 below 289. Answer 41. Next question. How many numbers are there which are exactly divisible by 4 and 3 up to 750? Let's see how can solve this question. Here the number asked is up to 750. So let's fix the upper limit 750. And we can see that here there are two divisors 4 and 3. So we have to take least common multiple of the divisors 4 and 3. LCM of 4 and 3 is 4 into 3 equal to 12. On dividing 750 by 12, we get quotient 62. That is, there are 62 numbers from 750 and below which are exactly divisible by 4 and 3. Let's solve the problem. Let's take LCM of 4 and 3. That is 4 into 3 equal to 12. Now let's divide 750 by 12. 6 into 12 is 72. Remainder 3. Drop down 0. 12 into 2 is 24. Remainder 6. Here we get the quotient 62. Thus it is clear that there are 62 numbers which are exactly divisible by 4 and 3 from 750 and below. Answer 62. Next question. How many multiples of 5 are there in between 100 and 400? Let's see how can solve this problem. The given limit is in between 100 and 400. So we have to consider the numbers from 101 to 399. So we have to find the multiples of 5 from 0 to 399. Then find the multiples of 5 from 0 to 100. On subtracting the quotients, we get the number of multiples of 5 from 101 to 399. Let's find the answer. To find the number of multiples of 5 in between 100 and 400, we must fix the limit 100 and 399. On dividing 100 by 5, we get quotients 20. Now let's divide 399 by 5. 7 into 5, 35. Remainder 4. Drop down 9. 9 into 5, 45. Remainder 4. We get quotient 79. Subtract 20 from 79. We get 59. That is, there are 59 multiples of 5 in between 100 and 400. Answer 59. Next question. How many multiples of 7 are there from 70 to 700? Let's see how to find the answer. The given limit is from 70 to 700. That is, 70 and 700 are included in the limit. To find the number of multiples of 7 from 70 to 700, we must first find the number of multiples of 7 from 0 to 69 and then find the number of multiples of 7 from 0 to 700. On subtracting the quotients, we get the answer. Let's solve the question. The given limit is from 70 to 700 and the dividing limit must be 69 and 700. Let's divide 69 by 7. 9 7 63, remainder 6. Again let's divide 700 by 7. 177, remainder 0, and there is no other limit except 0, so put 2 zeros at the quotient. On subtracting the quotients 100 and 9, we get 91. That is, there are 91 multiples of 7 from 70 to 700. Answer 91. Next question. How many numbers are there in between 200 and 600 which are exactly divisible by 3, 4 and 6? Let's see how can find the answer. Here the given limit is in between 200 and 600. We have to find the number of multiples from 0 to 599 first, and then we have to find the number of multiples from 0 to 200. On subtracting the quotients, we get the number of multiples from 201 to 599. That will be the number of multiples in between 200 and 600. Moreover, here we have 3 divisors, 3, 4 and 6. So we have to find the least common multiple of the divisors 3, 4 and 6. LCM of the divisors 3, 4 and 6 is 12. Then divide the dividing limit 200 and 599 by 12. Then the difference of the quotients will give the required number. Let's solve the problem. To find the number of multiples of 3, 4 and 6 in between 200 and 600, we must divide 200 and 599 by the LCM of the divisors. Now let's find LCM of the divisors 3, 4 and 6. On dividing the divisors 3, 4 and 6 by 2, we get 3, 2 and 3. Again divide the remainders by 3, we get 1, 2, 1. So the LCM is 2 into 3 into 2, that is 12. Divide 200 by 12. 1, 12, 12. Remainder 8. Drop down 0. Six into 12 is 72. Remainder 8. Divide 599 by 12. 12 into 4, 48. Remainder 11. Drop down 9. 9 into 12 is 108. Remainder 11. On subtracting the quotients 16 from 49, we get 33. That is, there is 33 multiples of 3, 4 and 6 in between 200 and 600. Answer 33. Next question. How many 4-digit numbers are there which are multiples of 7? Let's see how can solve this problem. Let's write the lower and upper limit of the 4-digit numbers, that is 1000 and 9999. That is, the smallest 4-digit number is 1000 and the largest 4-digit number is 9999. Here we have to find the multiples of 7 from 1000 to 9999. When we divide 9999 by 7, we get number of multiples of 7 from 0 to 9999. And on dividing 999 by 7, we get the number of multiples of 7 from 0 to 999. On subtracting the quotients, we get the number of multiples of 7 from 1000 to 9999. Let's solve the problem. We know that lower limit of 4-digit numbers is 1000 and upper limit of 4-digit numbers is 9999. To find the number of multiples of 7 from 1000, we must reduce the lower limit 1000 by 1. That is, the lower limit must be 999. Divide 999 by 7. 177, remainder 2, drop down 9. 4728, remainder 1, drop down 9. 2714, remainder 5. Divide 9999 by 7. 177, remainder 2, drop down 9. 4728, remainder 1 and drop down 9. 2714, remainder 5, drop down 9. 8756, remainder 3. On subtracting the quotients, 142 from 1428, we get 8 minus 2 is 6, 12 minus 4 is 8, 3 minus 1 is 2 and drop down 1. That is 1286. Answer 1286. Next question. How many multiples of 9 are there in between 100 and 999? Let's see how we can solve this problem. The given limit is in between 100 and 999. The upper limit must be reduced by 1 because we have to find the number of multiples of 9 till 998. When we divide 998 by 9, we get the number of multiples of 9 from 0 to 998. On dividing 100 by 9, we get the number of multiples of 9 from 0 to 100. On subtracting the quotients, we get the number of multiples of 9 from 101 to 998. That is the number of multiples of 9 in between 100 and 999. Let's solve the problem. The given limit is in between 100 and 999. To find the number of multiples between 100 and 999, we must reduce the upper limit by 1. Then the dividing limit must be 100 and 998. Divide 100 by 9. 199, remainder 1, drop down 0. 199, remainder 1. Divide 998 by 9. 199, remainder 0, drop down 9. 199, remainder 0, drop down 8. 8 is less than the divisor 9, so put a 0 at the quotient. On subtracting the quotient 11 from 110, we get 99. That is, there are 99 multiples of 9 in between 100 and 999. Answer 99. Next question. What is the remainder when 47 into 86 is divided by 3? Let's see how we can solve this problem. Find the first remainder on dividing the first number 47 by the given divisor 3. Find the second remainder on dividing the second number 86 by the given divisor 3. Then multiply the first remainder by the second remainder. As the product is greater than the given divisor, find the remainder on dividing the product by the given divisor. The third remainder we get must be the answer. Let's solve the problem. Let's divide the first number 47 by the given divisor 3. 1, 3, 3, remainder 1, drop down 7. 5, 3, 15, remainder 2. And again divide the second number 86 by the given divisor 3. 2 into 3, 6. 8 minus 6, 2. Drop down 6. 8 into 3, 24. 26 minus 24 is 2. That is, the second remainder is 2. On multiplying the first remainder by the second remainder, we get 2 into 2 is 4, which is greater than the given divisor 3. So divide the product by the given divisor 3, we get 133, remainder 1. That is, on dividing the product 47 into 86 by the given divisor 3, we get remainder 1. Answer 1. Next question. What will be the remainder when 49 raised to 27 is divided by 3? Let's see how we can find the answer. Divide 49 by 3. On dividing 49 by 3, we get remainder 1. 49 minus 48 equal to 1. That is, when we divide 49 raised to 27 by 3, we get remainder 1 raised to 27. 1 raised to 27 equal to 1. That's the required answer. Let's solve the problem. Divide 49 by 3. 1 into 3 is 3. Remainder 1. Drop down 9. 6 into 3 is 18 and remainder 1. On dividing 49 by 3, we get remainder 1. So, on dividing 49 raised to 27 by 3, we get remainder 1 raised to 27. 1 raised to 27 equal to 1. Answer 1. Next question. What's the remainder when 13 raised to 4 is divided by 4? Let's see how we can solve this problem. Divide 13 by 4. 3 into 4 equal to 12. 13 minus 12 equal to 1. On dividing 13 by 4, we get remainder 1. So, on dividing 13 raised to 4 by 4, we get remainder 1 raised to 4. One raised to 4 equal to 1. Answer 1. Next question. What's the remainder when 129 raised to 3 is divided by 7? Let's see how we can find the answer. On dividing 129 by 7, we get remainder 3. So, on dividing 129 cube by 7, we get remainder 3 cube. 3 cube is 3 into 3 into 3 equal to 27. As 27 is greater than the divisor 7, divide 27 by 7. On dividing 27 by 7, we get remainder 6. That is, on dividing 129 cube by 7, we get remainder 6. Let's solve the problem. Divide 129 by 7. 1 into 7, 7. 12 minus 7 is 5. Drop down 9. 8 into 7, 56. 59 minus 56 is 3. That is, on dividing 129 by 7, we get remainder 3. So, on dividing 129 cube by 7, we get remainder 3 cube. 3 cube equal to 3 into 3 into 3, that is 27. As 27 is greater than the divisor 7, divide 27 by 7. 3 into 7 equal to 21. 27 minus 21 equal to 6. That is, on dividing 129 cube by 7, we get remainder 6. Answer 6. Next question. What will be the remainder when 899 into 327 is divided by 7? Let's see how we can find the answer. When we divide 899 by 7, it leaves remainder 3. And on dividing 327 by 7, it leaves remainder 5. Multiply the first remainder by the second remainder, that is 3 into 5 equal to 15. The product of remainder 15 is greater than the divisor 7, so when we divide 15 by 7, it leaves remainder 1. That is, when we divide the product of 899 and 327 by 7, it leaves remainder 1. Let's solve the problem. Divide 899 by 7. 1 into 7 is 7. Remainder 1. Drop down 9. 2 into 7 is 14. Remainder 5 and drop down 9. 7 into 8 is 56. 59 minus 56 is 3. So best remainder is 3. Divide 327 by 7. 7 into 4 equal to 28. 32 minus 28 is 4. Drop down 7. 7 into 6 equal to 42. 47 minus 42 is 5. Second remainder equal to 5. Multiply the first remainder by the second remainder, that is 3 into 5 equal to 15, which is greater than the divisor 7. So divide the product by the divisor 7. 7 into 2 is 14, remainder 1. That is, when we divide the product 899 into 327 by 7, it leaves remainder 1. Answer 1. Next question. When a number is divided by 7, it leaves a remainder 3. What will be the remainder when the square of the number is divided by 7? Let's see how we can find the answer. We know that when we divide a number by a divisor, it leaves remainder r. Then if we divide square of the number by the same divisor, it leaves remainder r square. That is, if a number is divided by 7, it leaves remainder 3. Then square of the number is divided by 7, it leaves remainder 3 square. 3 square is 9, and which is greater than the divisor. So divide 9 by 7. On dividing 9 by 7, we get remainder 2. Let's find the answer. We know that if n divided by 7 leaves remainder 3, then n square divided by 7 leaves remainder r square. R square equal to 9. As 9 is greater than the divisor 7, divide 9 by 7. On dividing 9 by 7, we get remainder 2. Answer 2. Next question. what will be the unit digit of the product of the numbers 432, 274 and 873? Let's solve the problem. On multiplying the unit digits of the numbers from right to left, we get 3 into 4 equal to 12. Write the unit digit 2 of the product 12 and leave remainder 1. On multiplying the unit digit of the product and unit digit of the last number, we get 2 into 2 equal to 4. Answer 4. Next question. When a number is divided by 84, it leaves a remainder 18. Then what will be the remainder when the number is divided by 12? Let's see how we can find the answer. Here, the first divisor 84 is a multiple of the second divisor 12. That is 12 into 7 equal to 84. Thus, the remainder we get on dividing the first remainder by the second divisor must be equal to the remainder we get on dividing the number by the second divisor 12. Let's solve the problem. It is given that on dividing a number by 84, it leaves remainder 18. And on dividing the first remainder 18 by the second divisor 12, it leaves remainder 6. Thus, it is clear that as the first remainder is a multiple of the second remainder, when we divide the number by 12, we get remainder 6. Answer 6. Next question. When a number is divided by 112, it leaves remainder 53. What will be the remainder when the number is divided by 16? Let's see how we can find the answer. It has given that when a certain number n is divided by 112, it leaves remainder 53. As the second divisor 16 is one of the multiples of the first divisor 112, the remainder we get on dividing the number by the second divisor 16 must be equal to the remainder we get on dividing the first remainder by the second divisor. Let's divide 53 by 16. 3 into 16 is 48. 53 minus 48 equal to 5. Answer 5. Next question. If the difference between two consecutive numbers is x, what may be the numbers? Let's find the answer. In this question, it has given that the difference between two consecutive numbers is x. But this data is not relevant to find the answer. So let's look into the answer options. There is a hint in the question that the numbers are consecutive. Thus, the numbers may be 9 and 10. Next question. If the difference between square of two consecutive even numbers is 76, find the numbers. Let's see how we can solve this problem. If the difference between square of two consecutive even numbers as given and as for the numbers, divide the difference of squares of two consecutive even numbers by 4. And on adding 1 to the resultant number and subtracting 1 from the resultant number, we get the required numbers. Let's divide 76 by 4. 1 into 4 is 4, 7 minus 4 equal to 3. Drop down 6. 9 into 4 equal to 36. 36 minus 36 equal to 0. D by 4 equal to 19. On subtracting 1 from 19, we get 18, and on adding 1 to 19, we get 20. Answer 18 and 20. Next question. Find the numbers if difference between square of two consecutive odd numbers is 64. Let's solve the problem. Divide the difference of squares of two consecutive odd numbers by 4 on subtracting 1 from the resultant number, and on adding 1 to the resultant number, we get the required numbers. Divide 64 by 4. 1 into 4 is 4. 6 minus 4 is 2. Drop down 4. 6 into 4 equal to 24. 24 minus 24 equal to 0. Difference of squares of odd numbers divided by 4 equal to 16. On subtracting 1 from 16, we get 15, and on adding 1 to 16, we get 17. 15 and 17 are the consecutive odd numbers that we require. Answer 15 and 17. Next question. There are some goats and some gooses in a farm. Total number of their legs are 210, and that of their heads are 65. How many goats are there? Let's see how we can solve this problem. On subtracting the total number of heads from half of the total number of legs, we get total number of goats. Let's solve the problem. Given that total number of heads is 65 and total number of legs is 210, and we know that total number of four-footed animals equal to half of the total number of legs minus total number of heads. You need not write this data, but keep it in your mind and follow the next step. Total number of four-footed animals equal to 210 by 2 minus 65. That's equal to 105 minus 65 equal to 40. Answer 40. Next question. A seller in a market has some gooses and some goats. Total number of their heads are 175 and that of their legs are 550. How many gooses are there? Let's see how we can find the answer. On subtracting total number of heads from half of the total number of legs, we get total number of four-footed animals. That is total number of goats. Total number of heads minus total number of goats equal to total number of gooses. Let's solve the problem. Given that total number of heads is 175 and total number of legs is 550, and we know that total number of four-footed animals equal to half of the total number of legs minus total number of heads, and total number of gooses equal to total number of heads minus total number of goats. You need not write this data, but keep it in your mind and follow the next step. Total number of goats equal to 550 by 2 minus 175. On dividing 550 by 2, we get 275. 275 minus 175, we get 100. That is, number of goats are 100. Total number of gooses equal to 175 minus 100. That's equal to 75. Answer 75. In this session, we discussed 35 questions with explanation and workout. For each question, we took an average time of 2 minutes. If you practice, you can solve these problems within seconds without pen and paper. Thank you.